Hey everyone, welcome to AMRs, AGVs, and Conveyor. Which technology should you pick? My name's Matt Haan. I work at SoftBank Robotics currently as a solution design consultant there. Lead a small group of other solution designers and have been there for about a year and a half at this point. Today we're talking about these three technologies in the material handling world, the how and why questions that we should be talking about when using these technologies, and then how some tips and tricks on how to use these inside of CET as an engineer or as a consultant. And especially talking about bridging the gap as a solution engineer or a consultant between your customers and your engineering teams in utilizing these technologies. So I will answer this question early. If you want to watch some other videos or check out some other presentations. But the answer is, it depends. This is a typical consulting answer, but it really is the truth on selecting these technologies and talking about the solutions that they provide. So I'm going to start out with the discussion around Conveyor. I think that's something a lot of people are very familiar with in the material handling world, especially with the maturity of the conveyor extensions inside of CET. And on the surface, it sounds pretty simple, right? So it's moving boxes from A to B. And all right, easy enough, right? But what do you need to do that? So transportation is easy, straight line, no worries. But then you start getting into the smaller quirks and functions around conveyor, right? So do you need curves? Do you need inclines and declines? Probably at some point you're going to start talking about some sortation, whether that's right angle transfers, wheel diverts, strip belt sorters, all the way up to shoe sorters. And before any of that, you probably need to accumulate, merge, and gap. So the thing about all of those are functions. And even at that point, we haven't asked some material handling 101 questions, which are, what are we handling? Boxes and totes are easy. All of those functions and technologies change when we're talking about moving pallets or parts racks or roll cages or parcels. The technology selection is totally different there. We're handling polybags, jiffies, and mailers. So we always need to start with kind of that material handling 101 before selecting any technologies around materials to be handled. But even there's a step higher that your customers are going to be concerned about. And that's sort of this divide between the features and functions of what a piece or small chunk of technology does and the whole solution that a customer is looking for. So they're buying material handling equipment to solve some pain point in their operations. There's a gap there between the features and functions that individual technologies provide and then what that technology is doing as an overall solution. So I'm going to start here with thinking about that via this pyramid, building up from the small components and sub-assemblies that make up different units. It's very easy to think about that from a conveyor perspective. And then really how those units build up into modules, subsystems, functional areas, and then ultimately solutions, or even to a higher level, vertical markets, where these actually are solving a problem and not performing a small function. So as a solution design engineer, as a consultant, you're bridging the gap here where your customers are focused at that solution level. They need an overall solution to their problem, dipping into the details on their specific operations for how a functional area works. So things like receiving, shipping, picking, packing, and then into some of the nitty-gritty on the subsystems that support those functions. Your engineering team is going to be looking at components, units, and if they're really good in developing at the module level, starting to dig into that space. Whereas when you're translating and being that bridge between your customer and your engineering team, consulting and solution design is really stretched across that area. And that's how you should be approaching selecting these technologies. So going back here, we can talk about these now from an AGV and an AMR perspective. So the material handling world loves their 3-letter acronyms, AGV and AMR. If you don't know specifically what those stand for, it's automated guided vehicle and autonomous mobile robot. You will find lots of articles from different providers, different consulting agencies, think pieces on sort of what the difference between these two are. Sometimes there are defining features there, broad generalizations. One of the most common ones is that a lot of those articles will mention it's not an AMR unless it can do dynamic obstacle avoidance and some of the smarter features like that. In reality, these terms are not concretely defined in the industry. It's really going to come down to what individual vendors are offering, the technologies that they use to support that nowadays in 2025, and how they want to market that to the industry. So a lot of the time, what you'll hear generally is AGV is the legacy term. So AGVs existed first back in the 60s, as early as that. And most of the time, up until very recently, these were fork truck-based solutions. So usually used for pallet handling. They were guided in some way, either by wires, magnets, tape lines, and had some predefined path that they could move across automatically. Really, the term AMR has come more recently, and it really highlights the changes there from each of these letters in AGV, right? So they've gone from automated to autonomous. So a lot more options for things like those decision points of being able to navigate around a predefined path inside of certain guide rails. Same goes there for guided versus mobile. So they've opened up from these physical predefined paths to natural features navigation using LiDAR, QR codes, different things like that that change how these are physically guided. And then vehicles to robots have really opened up the form factor of these. So now there are plenty of these AMRs or robots that are doing tasks that are not fork truck based or not vehicle based. They can be a lot smaller. They can be handling different kinds of materials. But at the end of the day, a lot of the tasks that are traditionally thought of as AGV tasks may now be done by an AMR or an AMF, an automated guided forklift. There are a lot of letters that you can swap into various parts of these acronyms. What's important really is not, is this an AGV or is this an AMR? It's what is this vendor or partner offering? Does it meet your ROI and does it solve your particular problems? So one way to look at this is forks versus no forks, right? That sort of splits these technologies down the line. If you need forks, you're looking at one vehicle. If you don't, you're looking at something else. But rarely is that simple. Even inside the world of, hey, I'm handling pallets or need a forklift vehicle, there's tons of nuance and models to all of those. So do you need a reach truck or do you just need stacker units or floor transportation, whether that's light duty, heavy duty, counterbalance? Is a reach truck not enough? Do you need the extra density that a VNA or very narrow aisle unit can provide there with a turret truck based vehicle? Tuggers fall into pretty similar categories, even though they don't have forks. There's a variety of options there for larger oversized material movement. And then plenty of models inside of all of these categories that further divide by weight, size, all your classic materials to be handled attributes. And then if we go to the other side and look at AMRs. So the most common, probably basic AMR are these platform AMRs, right? So some sort of mobile robot that's moving. They typically have some sort of lift plate or pedestal or mounting that can come under some sort of unit, lift it slightly, and transport that without the use of forks or other things like that. You can mount plenty of things to the top, whether that's a pedestal with a piece of conveyor for loading and unloading, plenty of other attachments there. Also very early on in the AMR world were shelving AMRs, shelving or rack AMRs. So popularized definitely by Kiva, that is now Amazon Robotics, but there are tons of vendors offering this solution nowadays. A totally different kind of AMR might be a pick assist AMR. So instead of being a goods to person based system, you're looking at pick assist. So basically adding AMRs into usually pre-existing picking operations where somebody might be picking to a cart or a pallet, and then having that robot either meet pickers or direct pickers across pick paths, optimizing that work and minimizing travel time. There's a whole suite out there of masted AMRs, so handling cases or totes from higher shelving units. These are sometimes called ACRs, or autonomous case handling robots. So things like High Robotics. BrightPick does this in a way where they actually also add the picking arm onto that masted AMR. There's a whole world of sorting robots as well. So using an AMR to transport a single item that then has access to tons of sorting destinations to be able to automatically sort individual items without conveyance. There's a whole world of shuttle-based AMRs as well. So instead of the traditional mounted static in-rack shuttles, ones that are able to either roam across levels or actually drive out of the racking. And then plenty very recently that also have the ability to climb racking themselves. So navigating on the floor, attaching to racking locations, climbing to retrieve bins for goods to person operations. So Exotech, Knop, High. There's a whole world not warehouse based. So there's developments in the floor cleaning robots that would all be considered AMRs, or serving robots as well. And plenty of things not mentioned on here that fall somewhere in between. One really good way that I've seen this presented is from this company, STIQ Style Intelligence. They provide tons of free market reports for the material handling, automation, robotics industry. This is a slide from one of their AMR and AGV presentations that I think really summarizes a lot of what I've gone through here pretty well. There are major categories in here that all provide different applications and different functionality, but there's lots of gray areas in between those. You can't say all AGVs follow this certain paradigm, but generally they fall into these different categories, generally using these different kinds of navigation or load handling attributes. So highly recommend, if you are in this industry or seriously considering any of these technologies, to take a look at these reports. So all those different AMRs that we talked about are units, right? If I were to say what's better, Tompkins T-Sort or an Exotech SkyPod, the question is more complicated than that, right? Because fundamentally, both of those units are doing completely different things. Those companies offer solutions for different functional areas of the warehouse. The T-sort is a sorting system. Exotech is a goods to person sequencing automated storage and retrieval system. So really, there's asking what's better or what technology to pick isn't quite the right question. It's about, at the end of the day, what solution are you looking for? What operational problems do you have? And how can these different technologies help solve that? It's still worth going over a little bit of the pros and cons as you are evaluating these. There are lots of opportunities where conveyors or AMRs or AGVs can solve a particular problem. So even then, we do still want to talk about some of the pros and cons just inherent to these different technologies when you are making that choice. Thinking especially from just a transportation perspective, there are some clear differences that come out. If we're talking about conveyor first, one of the biggest pros of conveyor is really how long it's been around, how proven and reliable conveyor systems are, and most of the conveyor technology out in the market. Those are all machines that have run millions of hours of product over them, and definitely have high reliability, high product maturity. There's also really no comparison when we're talking smaller scale movement that conveyor will basically always be the highest throughput option, whether that's just sorting or transportation. Conveyor being fixed there, being able to run 200, 300 feet per minute is an option that most AMRs and AGVs can't compete with. As safe as AMRs and AGV systems are, especially in 2025, there is something to be said about safety related to conveyors. That conveyor is going to be in the exact same spot when you come back an hour, a day, or a week later. The same can't be said about an AGV. So you have the ability to have fixed guarding, clear safety areas and requirements that are built on physical infrastructure and not reliant on sensors. But with all of that comes some downsides for conveyor, right? That whole concept of it being in the same spot in an hour or a day can be a downside. Conveyor can really quickly create walls. And then at that point, getting into areas where you're interacting with conveyor, getting the product out of areas where you need a lot of operators, requires things like costly spirals, inclines, ceiling hung conveyor, just to accommodate egress and access. Anytime you want to make a change to a conveyor system, you're going to require remobilizing installation teams, engineering teams to come out to site, make those changes, commission them, test them, and make sure that that new equipment is in the new spot operating properly. And conveyor can also be a single point of failure. So if one conveyor line jams or a sorter induct goes down for whatever reason, chances are there's not a redundant system for that a lot of the time. So one single point of failure can shut down shipping for an entire system. And when we look at the flip side on AMRs and AGVs, immediately you have the pro of most of what you're designing in an AGV or an AMR system are aisles and not equipment. So those vehicles are not there all the time, which means you can have transportation through areas that people, non-automated vehicles, and things like that can pass through. A lot of the changes of the system can be made programmatically. You don't always need a physical change to change operations or paths to go along with that. And most AMR and AGV systems are going to have a level of redundancy that conveyor does not. So like we were saying before, if a conveyor goes down, that whole system is down at that point. Whereas when you have multiple AGVs, if one were to fail, chances are maybe just the product stored on that, if it's a shelf AMR like this, is inaccessible, but the stations picking from it or the movement that needs to happen can be absorbed by other vehicles in the system. On the downside to those, though, there is a higher barrier to entry on any AMR or AGV system. There's no equivalent of gravity conveyor or dumb accumulation for AMRs and AGVs. You are going to be likely very software dependent. Hopefully having a mature WMS at the very least in your building, likely a WES for execution, not to mention the fleet management system directly overseeing any of the robots. You need to plan space differently with AMRs too. So you do need to plan extra space for things like charging, things like maintenance for the vehicles, because that's not done directly at the point of work like it would be on a piece of conveyor. And then the last, as safe as these systems are, they require complex safety systems, which brings cost, and you really need to have an organizational culture that's going to work well with these automated vehicles. All right. So I hope that at this point it's clear there's no one-size-fits-all answer on which of these technologies you should pick. It really comes down to the individual customers, their operation, what functions they need to perform. And chances are there's going to be different answers for those specific problems and tasks. Most often, all of these are combined in large, highly integrated systems. They each perform different pieces of that system in the spot where they make the most sense. For instance, your answer right now may just be to combine pick assist AMR technology with traditional conveyor packing and shipping systems. These can all work together, and you should really be looking at where those different technologies fit for your specific problems. So work with the vendors that provide these technologies, work with dedicated system integrators or consultants to go through starting with what your problems are, what data do you have, what's your growth plan, and what's your budget. From there, we'll go into some CET-specific use cases here. And I'm going to start with conveyor here, but a lot of the way I look at CET, especially the essentials package for material handling, is that CET shines really well as a space planning tool. So it's a lot more than just maybe the piece of equipment that you're trying to sell that has a dollar value attached to it, but really taking that equipment and using CET to explain to a customer why they need that equipment and how it's going to work. Whether it's a nice render coming out of CET, if it's an installation drawing, 2D print, anything like that, all of those are communication tools. And at the end of the day, you're just trying to communicate something to someone else. And CET gives you a lot of flexibility in picking which of those tools make the most sense for whatever you're trying to communicate. So starting with conveyor and building on kind of that idea of using CET to help explain this technology. For plenty of people in the industry, this will be pretty self-explanatory of what is going on here. They can probably take a pretty educated guess at what these conveyors are doing, what these weird red boxes are. But, and this shows everything that you're maybe offering or selling to a customer. But really taking the time to add in your operational set dressing to help customers explain and understand how this system is going to work. They're not concerned with, how this conveyor stacks up, but more of how their employees, how their operators are going to use that equipment. So you can add the context of put your operators in where they're going to be working. Make that clear that, hey, somebody's going to be standing in front of each of these auto store ports. show what they're interacting with. So you can show empty cartons queued up. Both small and large sizes are going to be coming, 2 different capacities to these stations. They accumulate up top, and then you can see where the operator is going to pick into their carton. A lot of customers you'll be talking to, this may be their first automated system here. So maybe they're used to picking by RF device or even paper, and answering questions for them of like, okay, well, now how does this person standing in front of this port know what to do? So show things like your monitors that, hey, there's going to be, a screen here that's directing the operator exactly what to pick, how many to pick, when that order is complete, all of that information. From there, CET is really great at showing photorealistic work. So you can make this system look exactly like it's going to look in reality. Or one of the options that you can employ is taking that idea of communication to the next level by using things like color that may not be realistic. I'm not going to provide blue chutes here, but it gives you the opportunity to make what's happening clearer in the system. You can say, hey, your blue lines are your empty carton accumulation, your red lines are your outbound conveyance, your green positions are where we're picking items to. So it's not photorealistic, but it gives a different level of communication to these pictures. Similar things go for just other good solution development practices, right? So, you're not selling egress access, but it's important to show customers that you're considering it, that you have a means of getting in and out of these different areas, that the system you're providing isn't blocking someone there. So use your egress paths, use filters in CET if you don't want to see it all the time. And then use those different paths both in 2D and in 3D to the point where you don't need to, early on in the solution development process, do a 2D elevation to show here that, hey, we have walk clearance under this conveyor. If you have the block, say that it's the 2.1 meters that you need to walk under, and move on there. You can color code those too, so that across the building, everyone understands that these are my pedestrian paths, these are my industrial truck paths, and that's really clear and communicative. And then also, be sure to show that you're thinking about not just access, but maintainability. So you don't necessarily need to add things here, but just small details about making sure that, hey, what you design can actually be maintained, that you have access into these areas, that if a drive needs to be replaced or a belt, that you can physically get to that equipment and do it. I know it's nothing CET specific, but it's always the case of you can install a conveyor just about anywhere. That doesn't mean you can maintain it. All right, finally, we'll jump into CET and talk about some of the tools that I use in here for designing with AGVs and AMRs. So like I mentioned before, a lot of the time what you're really designing there are your aisles, your movement paths, not the equipment, but those movements and then the interfaces with your fixed equipment, whether you're picking up a pallet off the end of a conveyor line or you're interacting with staging locations like this, or even small, intricate tote AMR movements, right? So CET is really great at designing those small interactions, and going through the options that we have for tools. So the first one I'll mention is just a part of the robotics demo extension. So that means it's not officially released yet, but there are definitely some good starting ideas here that are worth testing out more, and hopefully will be developed into a full essentials release here. So at its most basic, you're able to add lines here to sketch AGV paths. So I've already got some of this in. We can work on a loop. Maybe you have some racking included in here. Those just drop in and connect with some simple options to turn those arrows on and off or change directions or make them bi-directional. A lot of times if we're thinking, fork-based AMRs, maybe we've unloaded trailers into a staging area like this. There's also tools to be able to draw multiple lines. So if you're setting up a layout where you need a vehicle to come in and pick all these pallet staging locations, you can use this tool. Start with middle here. It's asking for basically dimensions to build out the rest of this flow. So you can pick another middle point, copy these across, extend them up to the rest of the line, and then select all of them and make them bi-directional. So a vehicle would come in, pick from that row, come out, head on its way. And when you're happy with all the paths that you've drawn, you can select all of those. And then there's this option here to finalize the AGV path. And so what that's going to do is connect all those paths that you put together with some inputs that you can adjust here. So you can set the actual width of the path, how wide the machine is that's running, which you'll see is the light gray line here, plus a fixed safety distance around that. Turning radius you can adjust here too. If I were to make that smaller or larger, we can see how those curves are added and all those interaction points. And you can also show all of that in 3D as well. But just to note, there isn't a vertical aspect of this. So if you're worried about, the mast on a reach truck needing to clear some specific area, that's when we'll have to get into some of these other tools. But you can also, if you do want to make changes to that, revert that whole thing to a sketch, make your changes, and then finalize that path again. There's going to be some limitations with that. Like I mentioned, the verticality is missing. You can't really use it for AGVs that, for instance, don't have a turn radius, don't have a differential drive, and maybe turn on a 0-point turn, or confined axis there. The pathing isn't the most detailed as well, and oftentimes those curves, for instance, have less direct turning. They'll require extra clearance for that vehicle swing as it moves through. And then the safety barriers as well are often not fixed. So the distance that you need from, an AGV, for instance, might be different if it's passing another AGV, if it's a fixed point like a column or racking upright, or if it's passing pedestrian areas. So a lot of times those are all different values. When you're running into situations like that, I usually lean towards this industrial marking and signage tool. So we talked about using these egress paths just as exactly that, as egress. If you know you need a 3-meter aisle, you can easily do that. Say I want all my automatic forklift paths to be blue, color it there and plan around that. Something else I'll use a lot with this is, instead of just drawing the path, actually using this to draw the safety barriers. So if I set this here red on the left side, I know that on this route, all these fixed points, I need a 400 millimeter clearance. I'll include that specifically and just build pads and clearances there, and know that I need that clearance, and then I can easily move that down here. If I were to have a pedestrian aisle on the other side, if that needs 600 millimeters, I can change that and sort of build up those aisles and those clearances all together. You can also use floor tape for all of this. If you just wanted to tape out those areas or those paths, those are options too. Depending on the situation, I'll use one or the other. There's lots of options here too on changing these. You can use strips, dots. Arrows are very nice to add on to those paths if the direction is going to be fixed. Maybe you only have one-way traffic down a certain route. You can flip those around, change the material, and all your dimensions as well. The last one in here that I'll use pretty often is parking. So this basically is a tool to let you draw very quickly parking spots. So for AGVs and AMRs, at the very least, you're going to need different charging locations. So whether that's in-floor mounted contact that the robot has to pull into, or back into sort of extending charge points, you can use this tool to really easily define how big those spots need to be, drop them into the layout, and once again, show your customer, this is where I'm planning to do all this charging work. Any issues getting power there, start those discussions early, and show that you have that space reserved. Also, we can talk about pallet racking. So like with the safety clearances here, if you are doing any AGVs, AMFs, forklifts that are going to be interacting with racking, be sure to work with that specific vendor, that engineering team, to work out what dimensions they need in that racking for the AGV, whether that's pallet to pallet, pallet to upright, these different load to beam dimensions that they need to make sure that they function well. You can build that all into your pre-configurator here, save those templates and reuse them again. Other than sort of those common dimensions, a lot of the time there will be restrictions on specifically the top row, the liftoff needed there compared to where the mast will potentially conflict with the ceiling, and sometimes extra clearance needed on the bottom level if you are storing on the floor, just based on how those reach truck forks work. So you can keep all of that in there. And then one other tool, if you are working with vehicle blocks instead of paths, edit graphics here is going to be your best friend. Especially if you're working on concepts that maybe you don't have good vehicle drawings, 3D models, anything like that. Edit graphics is a really good tool just in general in CET here, but especially in situations where you can drop in this generic AGV from industrial equipment, but maybe these dimensions aren't quite right. You do have the option to just scale it generally here, but what edit graphics is going to do is let you really make this generic unit much closer to the realistic dimensions of the vehicle you're working with. So you can just click Make Editable, select this block here, and you'll see it turn orange. You can just go ahead and stretch. You can pick a face and then stretch the unit. But what this is going to do is stretch everything the same way. So you'll see that drive wheel there getting really elongated, not exactly what we would want. So the best tool to use in here is when you select this model to go ahead and add your cut planes. So this lets you add them in the X, Y, Z different dimensions. So I'll add one here in the Y, and I'm selecting that, defining that cut plane, and that basically becomes the point that is replicated when you go to stretch a block. So now everything to the left of this cut plane, everything to the right is not actually going to change when you go to stretch it. It's just that cut plane that's going to get extended. So if you go to stretch it now, that block gets updated, but your wheels stay round, and you can do the same thing in your other directions here. So you can define that cut plane, stretch it without messing with proportions. So that's great for just creating this generic AGV of whatever specific size you're looking at to show in the layout and work from there. Your textures may get messed up like this, so you can go ahead and just apply custom ones. The other point that I really like to use here, if for instance this were an AGV that instead of having drive wheels like this that took a curve, was omnidirectional or turned just on its center axis, using these 3D tools, finding the center point of that object and dropping a circle that's going to encompass everything. I like to just put that right on the ground, make it like 5 millimeters. Oops. 5 millimeters thick. And then just applying a transparent texture to it. A lot of times I'll make it not show in 2D, just show that outline. But then you have this, you can also just duplicate that. If you look at your center point again and add in the extra radius that you would need for your safety clearance. Maybe go ahead and make that one a red transparency. And then you know exactly when you're designing this interface, laying out any of the equipment here, exactly what kind of space you need if you were to do a zero turn setup. Throw those into a block, and then anytime you move this around, copy it, you've got that turning clearance included with the vehicle.